Well, thank you all afternoon, and thanks for joining us for this webinar. We're going to be covering preparing for heat pump projects, and we'll be hearing from some of our expert installers who'll be giving their practical advice from their decades of experience. Just to introduce myself, I'm Andrew Todd. I'm Sureserve's Head of Net Zero Carbon, and I'll introduce our installers later on. So what we'll be covering today, a bit about Sureserve and our role in delivering heat pump projects, amongst other things in the social housing sector. We'll then talk about the social housing fund, warm homes, and the spotlight that's on low carbon heating for wave 3. We'll go over then some logistics of heat pump projects, a bit around the sizing, covering permitted development, because there's been some latest changes which are actually just released today. So we'll go through those and talk about the external unit location before turning over to our experts for their insights, and then Q&A at the end. There should be plenty of time for Q&A, so you can either come off mic and camera then and ask your questions. We'd encourage that. Like to see your faces, or you can log them in the chat function, and one of our team will ask them. And there's a couple of polls that we'll be running just to get your insights and opinions on things. So please do take part in those. A brief introduction to Sureserve. We work across the compliance and energy services for social housing and public and commercial building sectors. And we're playing a key and progressive role in decarbonisation, facilitating the energy transition. And as you can see from the map, we've got good coverage across Great Britain, delivered schemes in all geographies, and we've got employees of around 3,700, 60% of which are engineers. So boots on the ground out there fixing and repairing heating systems and installing new low carbon heating and renewables. We cover the big 6 of building safety and compliance, and increasingly we're starting to cover damp and mold checks as well for the homes that we're in, helping to spot and remediate issues early and protecting residents, and also helping housing providers with compliance with OAB's law. And then on the energy transition side, we're leading social housing providers on their decarbonisation journeys, from typically the start position of predominantly fossil fuel heating systems towards a fully decarbonised housing stock. This would typically involve looking at housing stock data and developing long-term programs of retrofit, looking at opportunities for fabric improvements and ventilation, and then where we can upgrade renewable heating systems and inclusion of solar PV and batteries, and then monitoring homes post-retrofit to ensure buildings and heating systems are performing as intended, and looking out for opportunities for preventative maintenance. This data on screen shows our installation numbers for low carbon heating and renewable and fabric technologies in 2024. And these cover all of the major government grant funded schemes. And we're also gearing up to deliver many more in 2025 under the Warm Homes Social Housing Fund and the Warm Homes Local Grant, which we've got the full set of accreditations to deliver. And then we also have over 12,000 heat pump systems under service and repair contracts. The majority of those are air source heat pumps, about 10,000, but then various ground source, water source and exhaust air heat pumps. And so all of the insights that we gain from servicing and repairing these heating systems are fed back into our expert installer team. So they learn what works well and what doesn't in terms of how these heating systems are installed. Right, yes, so we've got the first polls where we want to hear from you. So I think firstly we want to understand your experience of delivering heat pump projects. So those will be launched, and then my lovely colleague Mari will help to feed me the results because I can't see the screen, unfortunately.
So far we're looking at kind of 50-50. Well, it's changing all the time. But we have people who have not yet installed but are planning to, some who have delivered, and some who have done some individual but not at scale. So it's about 40 not at scale, 40% that have not installed but have some planning in place, and about 20% who have started to scale up.
Okay, great. So a good mix, and I'm sure that's probably common across the sector. People are starting to see heat pumps as the main technology of choice for decarbonising heating systems. So starting to gain experience on those projects. The second poll then, if that could be launched, we'd like to understand your perceptions of heat pump projects. So there's a bit of, is there nervousness, or are you fully behind them? So Mari, once the results come trickling through, if you could just let me know what it's looking like.
So it's just going into the voting now as well, and we've got some who are a bit nervous about the technology, some who are interested in learning a bit more, about 50% are, and 25% are excited about rolling it out. Oh, that's gone up to 40. Good, the excitement is up.
Great.
So yeah, most are sort of 40 and 40 for the second and third answers, about interested and excited.
Great, thanks, Mari. Well, for those who are nervous, hopefully, throughout this webinar, you'll be able to ask questions for the expert installers. We'll be able to kind of hopefully bust some of the myths around heat pumps and ease some of those nerves. So a brief spotlight then on Warm Homes. Hopefully, if you're doing your Warm Home Social Housing Fund Wave 3 application, that's really all underway, nearly wrapped up, final checks and then submission next Monday. We know it's a really, really tough and stressful time, so yeah, really wish you all the best of luck with those. Wave 3, you would have noticed, marks a significant change in that there's more active encouragement from DESNZ of applications with low carbon heat technologies in them, with the strategic priorities section of the guidance giving more points to applicants that install low carbon heating at scale. They want to see that growth in low carbon heating, and particularly in air source heat pumps, and they want to see kind of good case studies coming off the back of them. As with previous waves, the same kind of criteria apply, and that bills shouldn't increase as a result of replacing heating systems. So that might mean you need to do some fabric improvements as well. But you need to really kind of take care of the modelling of the heating system upgrades to make sure you are proving that bills don't go up. Properties aren't eligible if they've received other sources of funding, such as the Renewable Heat Incentive or Boiler Upgrade Scheme. And then eligible low carbon heat technologies must be SAP compliant. And then in terms of the list of priority low carbon heat technologies, air to water heat pumps or low carbon heat networks are at the top of the list, then shared ground loops and ground source heating, air to air, biomass, but only in rural areas where there's no air quality issues, heat batteries, and then high heat retention storage heaters for smaller properties, which are particularly electric heated. Quick note on hybrid systems, which Sureserve do see as a useful transition technology on the route to decarbonising our homes, particularly given the kind of behavioural adaptations that are required for some of the technologies. So they are eligible under Warm Homes, but with certain caveats. In terms of what is eligible, there could either be a new system made up of several units, it could be a fully integrated system in one unit, or heat pumps installed alongside existing A-rated gas boilers. The caveats are that the retrofit coordinators must be satisfied that the boiler's in good working conditions, and that they've investigated other options for upgrading to standalone heat pumps where possible. But yeah, it's worth exploring these, and we can also take questions on hybrid heating systems later on. In terms of the logistics of heat pump projects, just like any retrofit projects, they really need to be well planned in order to manage any issues and risks. So during the planning stage, you'll have to be clear about the start and end dates of the project, both for individual dwellings, but also the projects as a whole. You'll need to plan for access during during installation, accessing inside and outside the homes. And you'll need to conduct appropriate risk assessments and health and safety plans that cover both your contractors and residents, particularly if they're staying in the homes during the retrofits. During the installation phase, then, you'll need to consider how to get heavy plant to site, the time residents that will need to be without heat and hot water, and whether or not you're providing any alternatives to cover them. And remember that resident disruption will be significant during this period, and needs really, really good resident liaison from an early stage. We'll cover some aspects of resident engagement later on. And then post-installation, making sure that your DNO and any planning applications, if required, are submitted in good time, that the future maintenance and repair schedules are considered for your heating systems, and that they're well budgeted, who's doing what. Heat pump sizing is crucial to good operational efficiency. You need to really play that balance of over or undersizing and try and get it just right. If you undersize things, you might struggle to meet the heating load, not water demands, leading to running the heat pump continuously, which can increase energy bills and lead to more maintenance and possibly a shorter lifespan. Oversizing it, and you're unnecessarily increasing the capital cost, and the heat pump could short cycle, which means it's frequently turning on and off. That can lead to reduced efficiency and increased maintenance. So do double check things with your installer, who should be carrying out room-to-room heat loss calculations and sizing the heat pump effectively. Also checking pipework, radiators, and other heat emitters. There's also useful guides under the microgeneration certification scheme, the MCS website, which we'd recommend checking out, which would help upskill your teams on how to approach heat pump sizing. So when we're looking at heat emitters, pipework and cylinders, again, it's crucial that these are well sized to get the best performance out of your heat pumps. They're going to be heat pumps are more efficient when we've got lower flow temperatures than we see with gas boilers. However, there are some high temperature units available. But good flow is achieved through effective pipework. And if your pipework is small, so micro bore pipework, which has a diameter of less than 15 mils, that's going to really restrict flow. And also plastic micro bore can further compound the issues. It doesn't necessarily mean that you'll need to upgrade things, but your designer or installer should have that view on whether or not your pipework needs upgrading to be suitable for your heat pumps. In terms of cylinders, heat pumps don't produce hot water on demand, so you need a hot water source like a cylinder to work alongside your heat pump. These can be quite large, and particularly if you're switching homes with combi boilers to heat pumps, where you wouldn't typically have a hot water cylinder before, you need to think about where the cylinders go and communicate this early on with your residents, because they might lose some useful cupboard space in order to house the cylinder. So that just needs to be really delicately covered and communicated. To get the same heat output from a heat pump with a lower flow temperature, you might need to increase the surface area of your heat emitters. So that might include replacing some of the radiators with larger models. Again, you need to think about how that can happen in practice and the space implications within the homes. But sometimes radiators don't need replacing; they might already be oversized and ready to take on heat pumps. And again, do check with your heating engineer, your installer, who'll be able to give you that view as to whether or not your radiators need replacing. Okay, so quickly on permitted development, air source heat pumps can be installed under permitted development rights, but subject to certain conditions. And as I mentioned, there's been some upgrades, some updates on these, which were announced just this morning, which I've highlighted. Some of the key points then of permitted development are that you can only install one heat pump per property as permitted development. And the change that was announced today is the size of the outdoor unit should now be no bigger than 1.5 cubic meters, which should normally be the case in terms of the units which are out there on the market. Another update is that the 1 meter from a property boundary rule in terms of where to house your external unit has been scrapped. So that was in place due to perceived noise complaints, but research has shown that they're actually not an issue. And so that's a really positive step forward to help unlock some of the planning issues to do with heat pump installs. In terms of installing on roofs, you can put them on a flat roof, can't put them on a pitched roof. If they're on a flat roof, they should be at least 1 meter from the edge of the roof. And I think the last point, the same development rights now apply to air-to-air heat pumps as to air-to-water. It's always worth checking with your local planning authorities whether or not permitted development applies to your heat pump projects. They'll have a really good understanding of the rules and regulations that apply, be able to guide you, which will help you when you're specifying and going out to your installers just to make sure that they get it all right within your requirements. So a bit on the external unit and how it's located. So it's not just about satisfying permitted development rights, it's about optimizing performance and efficiency. So you need to install the external unit on a flat level surface, which has good drainage for condensate. And it shouldn't be directly below a window for habitable rooms, habitable meaning bedrooms or living rooms. That's to avoid kind of noise disturbance and vibration as well. And ideally, it should be close to where the heat enters the building to avoid losing heat through long pipe runs. In terms of airflow, you need sufficient space around the unit to get that good airflow, because this is where the air, which is actually going to go into the heating system and heat your properties, is going to come from. You need to make sure you've got good access for maintenance and for service engineers to operate easily and effectively. So in that first picture, you might see it's kind of surrounded by a raised bed, which might not be that useful for the engineer who needs to take off the panel and work around it. And then in terms of weather, try and avoid spots where you might get extreme weather, which can really damage the operational efficiency and the lifetime of the units themselves. So look for those sheltered spots, which is going to really help you with maximizing performance. Excellent. So I think you've heard enough from me. So I'd like to turn over to a couple of our expert installers. So we've got Ryan Sterling, who's our renewable technology manager from Sureserve Energy Services, and Finbar Fitzpatrick, head of renewables from Sureserve Compliance South. So Ryan, perhaps you could just come on, introduce yourself, a bit about your experience in heat pumps, and then I'll ask you a couple of questions about the design and feasibility stages.
Yeah, so Ryan Sterling, renewable technical manager for Sureserve Energy Services. I've been in the industry just shy of 15 years now, working with heat pumps, all renewables really. And I practice what I preach because I've actually got a heat pump in my own house, so I'm not telling any lies about it.
Good stuff. Excellent. So in that initial feasibility stage, what should social housing providers really be looking out for in terms of their housing stock that might determine whether or not heat pumps are suitable for their homes?
In terms of the housing stock, an easy hit would probably be something that's maybe recently had some fabric upgrades done. You're looking for a more efficient property to sort of reap the benefits of a heat pump. Something maybe you've looked at PV and battery installations on, maybe about a mid-band D on an EPC and above. Something that's pretty much there and ready. It's usually a sort of go-to and outside a conservation zone because it adds time onto applications.
Yeah, brilliant. And I think there has been research that shows that heat pumps can be installed in any type of property, but getting that kind of fabric right is really a key first step. So could you just talk a bit more about the importance of reducing space heat demand for heat pumps and why that's important?
So obviously, the less heat loss through the building, the better. The more heat you need to provide to the property, the more electricity you use. We look at sort of the whole house approach. You're not just looking at sort of the customer's usage and try to save fuel bills. You're also looking at heat loss through loft insulation. If it's hard to treat properties, there's options for external wall insulation, underfloor. Every bit really does help in terms of running costs.
Yeah, brilliant. And in terms of some of those other aspects, I touched upon pipework and cylinders, but what are some of the key design considerations that housing associations should understand before approaching heat pump projects?
So I touched on it with external design temperatures. Depending where you are in the country, your external design temperatures will vary. If you take the likes of Wick up the north of Scotland, that could be an external design, I say -5, whereas down in Cornwall it might be -1. That's a big aspect for it because there's a drop off in efficiency in winter.
Yeah.
So although a heat pump might be rated at say 12 kilowatts, in the dead of winter, they may only be able to produce 8 kilowatts. So that's a big point to take in when you're sizing for a property to be able to meet the demand throughout the year.
Yeah, excellent. Yeah, so housing associations, local authorities, well, probably more HAs where they've got stock covering, a broad area of the country, they need to really consider, have I got the right design temperatures for my more northern stock compared to my more southerly stock?
Yeah, there's a huge emphasis on design. If everything's designed correctly and sort of to the standards, they'll work fantastic. It's tend to get a bad rep when people are cutting corners or they've not spent the time properly looking at the design aspects of it.
Yeah, excellent. And in terms of resident acceptability, that's obviously going to be key to project success. Just kind of getting foot through the door and making sure that we can upgrade the heating systems. So when and how should residents be initially engaged on projects involving heat pumps?
We always say the best thing to do is engage as early as possible. Whether that be through brochures, letters, community events are always great. Manufacturers as well are always keen to support. They've got sort of facilities where they've got vans with their units on them. They can bring them out. Tenants can see what can actually be going in their house, what's involved. It usually tends to be the best sort of method. The longer you've got to talk with them and explain how it works, talk through controls, the more to take in.
Yeah, brilliant. And what are some of the best methods then of communicating these projects to residents?
Engagement events are always great. Being there in person, they're absolutely fantastic. Brochures go a long way as well. Sometimes as well, we find it easier to maybe, instead of just doing an initial survey visit, there might be a couple of visits involved. Especially if you've got a property list in mind, that it can be engaging with tenants early on during the design process as well, so they know what to expect.
Yeah, brilliant. Okay, so early engagement and varied communication methods, I think, is really key. Cool. Okay, thanks, Ryan. Finbar, do you want to come on, introduce yourself, a bit about your experience within the renewable sector?
Yeah. Afternoon. Thanks, Andrew. Finbar Fitzpatrick, Head of Renewables at Sureserve Compliance South. Again, similar to Ryan, I've been involved with all types of renewables for just shy of 20 years now, from biomass through to your solar PV, solar thermal, air source. Exhaust air seems to be a really, really popular one as well at the moment. Mainly been sitting a lot on the service and repair side, but I've also done a lot of design and installation. Great
stuff. So you've kind of seen it all in terms of the good and the bad across the service and repair side. Talk us through the handover process then. So what involvement should housing providers have in the handover process, and what are some of the kind of key considerations for that?
Again, for the process for the housing associations or councils, the handover process is quite streamlined. We will take care of all of that as the contractor, from that initial heat loss design, heat pump siting, any kind of planning applications that we believe might need to run through from that, and any DNO kind of letting our network operators know afterwards on any connections we've made.
Okay, brilliant. So making the process as streamlined as possible by taking some of the more administrative burdens away from the HAs.
Yeah.
In terms of the service and repair side, so you mentioned that we're covering about 12,000 heat pump systems. Excuse me, many of which we've kind of inherited from other installers. So what have some of your experience of the issues that you're seeing in operation of heat pump systems, and how could they be resolved through either at design stage or at the kind of handover stage?
Yeah, so multiple different ones. I guess we inherit of, I would say, a small number are design stage issues, which are just minor tweaks. We do have an awful lot, I would say, probably 80% of most new handover stuff that gets sent is end user awareness. Unfortunately, that handover process of that end user tenant for our kind of tenants is understanding how a low temperature heating system works. So that whole process of they're unsure of the controls. It's not exactly like how they used to run their gas system. They've just been moved into, especially new blocks. We get a lot of new blocks being handed over to service and repair at the moment, and unfortunately that process is missing. So we have done, as Ryan said, a couple of engagement days where we've actually been into 2 or 3 properties, but kind of made ourselves available for that day to run through with anyone else that was quite keen. Once they're aware, it's really good. But I would say most of our call-outs from new build blocks is all down to just the end user being unaware of how it works. That's across all of it. That's across ventilation as well with their MVHRs. They're turning everything on and off at main switches and making everything very, very inefficient and not getting their desired needs out of it. So I think that's probably, I would harp on a little bit about that. That's a key one for me.
Yeah. So, talking about the main differences between traditional heating systems and how they're operated, which is more of a off-on switch or just turning the thermostat up at the wall in order to get your heat relatively quickly, which residents are having to adapt to. So what are some of the main operational differences, and how should heat pumps be operated by residents to make sure that we're avoiding some of the issues of low operational efficiencies and then service and repair?
Yeah, so I think Ryan touched on it a moment ago as well. What we're really looking to do is keep the heat within the property now. I think historically how we run our systems, we boosted them in the morning for that hour when we wanted the heat. We got 80 degrees running around the radiators. They were very touch to hot or hot to touch. And again, we done the same in the afternoon when it got cold again. We give it a boost for 1, 2, or 3 hours, even which our old controls are all set up for that 1, 2, 3 hour boost kind of functions. Whereas with our low temperature heating running, realistically at least half the temperature of our traditional gas systems or oil systems that have been running previously. It's training the mind a little bit. So people come in from it sounds silly, walking the dog in the afternoon when it's cold, you come in, they automatically turn around, put their hands up against a heater and expect to feel that 70 or 80 degrees that their mind's been trained to kind of capture over the last number of years. With our new style systems on your low temperature heating systems, you're looking at really keeping a steady temperature within the house, and maybe only doing a setback or a drop down of 1 or 2 degrees on the times that you're looking for it off. So as opposed to really going, if I was looking for a steady temperature at 21, previously what we would have always done is ran it to 23 or 4 and left it cool down to 15 or 16, and then just kept continuing that process. What we're looking at low temperature heating is just running it, if we're looking at that 20 degrees, 21 degrees, setting back to maybe 19 on our off periods, and then it's very easy for it to jump back up to that 1 or 2 degrees. It's basically key not to let it really drop right down.
Yeah. So that kind of lower but steady and constant level of heat, and it's that mindset change, isn't it, that we need to communicate to residents, that it's not going to change your overall comfort, but it's just going to change the kind of immediate perception of how you're getting your heat in your homes.
Yeah, absolutely. I think that's our biggest challenge over the next 5 years is that end user awareness of how the low temperature systems work. So I think that'll be one of our hurdles to get over. And the more and more engagement pieces that we do, and the more and more on-site stuff we do, and that's the only way we can really push that until we start seeing some ads on the TV for it. Really, I believe, from some of the big manufacturers.
Yes, exactly. Yeah, I mean, there's probably a whole public information campaign that's needed around heat pumps, as there was with smart meters, and you go back in time as there was with switching over to gas. But that's something we're not going to solve today, I don't think. In terms of this, probably a question for both of you, but what are your thoughts on higher temperature units and overcoming perhaps some of the behavioural issues we've talked about through high temperature heat pumps?
Yeah, again, for me personally, I think every one of the technologies have a place in the market, and it all boils back down to that initial design process. So we will always endeavour to look at the low temperature heating and the most efficient, but there will be times and places and certain fabrics that we will look towards a more high temperature set. Once we can get our efficiencies out of it. So I believe there's a place in there, and it will depend on that initial design and building fabric, really.
Yeah, brilliant. Brian, anything on top of
that? No, I completely agree with Finbar. To be honest, it does have its place in the market, but as it stands just now, fuel efficiency wise, low temperature is still the future. It's the most fuel efficient, especially for tenants.
So if we get the fabric right, you shouldn't have to look to high temperature unit, lower temperature units, cheaper bills for residents. Brilliant. Great. That's all the questions I had for you guys. Thank you. But do stay on. We've got the audience Q&A now. So I'm going to stop sharing my screen in a second. But if you want to get in touch to talk about heat pump projects, to talk about decarbonisation more generally, then you can either just email me or you can use that QR code and book a meeting directly. But what I'll do now is stop sharing screen, come on screen, and then please kind of fire away with any questions that you've got.
Hi, Andrew. I don't know if you can see the questions or not, but we've got a few. One that was shared ahead of the webinar because they weren't able to attend, but they'll watch the recording back, and a couple of others. So if I start with a question from George, are there, I guess it's to all of you, are there any circumstances where heat pumps can be installed in a conservation area, for example, with an appropriate sort of disguising cover or something there?
So I'll happy to jump in on that one. In terms of conservation areas, it's absolutely feasible. We've done it several occasions. It's you're more looking at, so you can't be visible from a main road or a highway. So you're looking at relocating them sort of maybe up the back of a garden, some trenching involved for pipe work, things like that. But it's absolutely feasible. I'd take every property individually at that though. It would need to be assessed one at a time.
Yeah, brilliant.
I'm trying to catch that. It's saying sort of off the actual property wall, so on the property itself, but not on the actual building. Is the way around it?
Yeah. So
the road
rear of a property, or possibly up the back of a garden type idea.
Brilliant.
Yeah.
And then I had kind of like, what are some of the direct benefits to residents? I think you touched on it actually in what you were saying, Andrew, and that there's a need for sort of public awareness. Why would they bother with the disruption of having it on there? How do you kind of sell that in, I guess?
I think that needs to be done over time, and we've alluded to the importance of speaking to your residents about the heat system changes that are going to come down the pipelines. There's the direction of policy and regulation is that gas heating systems are being phased out over time, and we're kind of committed to the decarbonisation agenda in the UK. So the heat sector, and particularly residential heating, makes up a significant proportion of our overall emissions. So it's just about kind of taking residents on that journey. And I think for residents as well, perhaps decarbonisation is not kind of top of their agenda, but just talking them through the benefits that they're going to get from changing the heating systems, which should be that kind of lower bills over time, particularly when we're tying in heat pump projects with fabric improvements and solar PV. And that kind of constant comfort as well, so improving the comfort of their homes.
Brilliant. So I've tried to capture that in the chat for anyone. Feel free, others, to chat, or we will bring everyone off of mute shortly so you can ask your questions as well. Last one was the one that was sort of sent ahead, which was, please could you help me? I want to know sort of where I can, as a housing provider, get information, independent information for myself and my residents, so that they can sort of, and maybe, get a look at something actually in situ and working to understand a bit more. It must be someone that's starting the beginning of their journey, really.
Again, I'm happy to start off on that. So we've had a number in a very similar process at the moment of our clients who were very interested to see stuff up and running. Across all the manufacturers we work very closely with, and some of our other clients, we've been able to bring clients along to look at operational, whether that is ground source, air source, or exhaust air at the moment, because I am a big believer in seeing, feeling, and touching the actual units to prove proof of concept, which I believe is part of your last question as well. That over this next few years, as more and more residents see their neighbours having fully operational units and it proves the concept, then that resident engagement will automatically rise just from that process alone. So yeah, again, for us personally, there's lots of the manufacturers will help with that. So if they wanted to lead towards a manufacturer, or to the likes of ourselves as a client, we're able to kind of push towards where we already have working units. And there is, again, as Ryan said, lots of them will do demonstration days with their kind of on tour vans now, which are really, really good. But there's nothing like seeing them in actual situ with a working client.
Just add to that, there's a lot of good independent advice now out there as well. So visit things like the Energy Saving Trust website for your kind of starting point. Nesta have they've got a project where you can actually go and visit a heat pump in operation. So I think that's really valuable, just to be able to kind of look and see the technology. Like Finbar said, there's a number of manufacturers where you can do a tour and visit heat pumps in operation and understand how the technology works from the manufacturer's voice, which we're happy to facilitate. And lastly, I would say try and develop kind of resident champions around this as well. So if you've had retrofit projects done in your homes, including fabric upgrades and heat pumps, then see if those residents can act as champions and talk to others about the benefits that they're seeing directly. Hearing about the benefits from another resident is probably the most valuable source of information for communicating it to your wider resident base. So try and think about developing those resident champions.
Brilliant, thank you. And then just one follow-up question on that conservation zone. Would it ever be suitable to perhaps put something at the front of the property? Maybe they don't have a garden, disguised box with some sort of disguised box. Is that something that conservation areas allow?
It would need to be sort of reviewed with the local planning committee, and a conservation area planning application is required. Usually a site visit will take place, at which point that can be discussed. I don't believe it's a major issue, it's just to what extent and what involvement's required. Just because, especially in areas of outstanding natural beauty, it tends to be a bit more protected.
Yeah, and I think the only thing about the box is that you need to make sure you've got good airflow around the heat pump unit as well. So yeah, cautious about enclosing it into something unless it's got the kind of correct flow temperatures, which really needs to be covered off by your designer. There are now, I think, different skins that you can put on the heat pump itself, so it doesn't have to be a big white box. It can be skinned to be different colours. It can be skin to mirror a brick pattern. So I think it's just about what your planning authority is comfortable with, and what your design is comfortable with in the end of the day.
Brilliant, thank you. I think that's all the questions I've got in review. So I don't know if Irina is able to sort of bring people off of mic if they would like to, or pop their hand up, raise their hand, and we could take questions from the virtual floor if that would be something people would be happy with. Not always my favourite. I'm a bit camera shy, but
No, you're not, Mari.
Yeah, actually, people can ask questions. If there are any volunteers, please just raise your hand or unmute yourself.
Okay. Doesn't seem like there's any further questions, but we will be sending the slides out to everyone. So do use the contact links in there if you want to get in touch. And like I said earlier, if you're working on your Wave 3 bids, good luck with the final days before submission. And yeah, we're looking forward to hearing from some of you in the future. Thank you all, and have a good rest of your afternoon.